first, a couple definitions. Perpendicular bisector, the name says what it is. This is an element that is perpendicular to a line or to a segment. And it passes through that segment's midpoint. And that allows it to be exactly what it says it is. It's both perpendicular, which means that in this case, line N is perpendicular to segment PQ. And it's a bisector. That means that PM and MQ are equal. Okay, so the word gives it away, but you might see this in a proof as just definition of perpendicular bisector. Okay, these remaining three are just relationships that exist here. So again, I'm going to write them down, show the sort of the equation or statement for them, and then we'll move on to the things that will be the heart of what we cover today. But the linear pair perpendicular theorem just states that if two lines intersect to form a linear pair, and that linear pair is congruent, then that means the lines are perpendicular. Okay, again, that would be something that is probably intuitive if you see it. You don't specifically need a relationship to talk through that, but that is a theorem that your textbook demonstrates. The other two theorems the textbook demonstrates are, again, relationships that are probably intuitive. They may come up in some of the homework type of problems, but the first one is in a given plane. If you have a transversal that's perpendicular to one of two parallel lines, then it's going to be perpendicular to the other one as well. Remember, transversal is a line that intersects multiple lines. So here, J is the, in this case, J is the transversal. So I have symbols here for perpendicular and parallel, but again, in a given plane, if a transversal is perpendicular to one of two parallel lines, then it's perpendicular to the other. So if J is perpendicular to H, and H is parallel to K, then the conclusion is J would be perpendicular to K as well. And then the final one is a similar type of relationship, just has a slightly different take on it. But if you're working in a plane, and if you have two lines that are perpendicular to the same line, then those lines are parallel to each other. So the relationship here would be if M is perpendicular to P and N is perpendicular to P. Those are two lines perpendicular to the same line. The conclusion is that M and N are parallel to each other. And so that would be the relationships you're looking at for section 3.4, which again, we're not going to spend a whole lot of time on, and the majority of the homework is going to be covering 3.5. Okay, and 3.5 is a relationship that you should have been exposed to in algebra. So you may already know these two relationships. The first is if you have two parallel lines, because of the nature of the slopes of these lines being the rise over run, if these lines never intersect, then as you go up on one and over, the only way that the two lines will never intersect is if you go up and over the exact same amount for each line. So the slopes of parallel lines are going to be the same. Okay, so here, if we took this blue line and said that its slope was a over b, then that means a parallel line, the red one here, would also have that slope a over b. Notice how I labeled these. It's m with a subscript of the symbol for parallel. Okay, so that's what that represents there. And then in contrast to that, if you have perpendicular lines, then their slopes are going to be negative reciprocals. Okay, and this means that they have a product of -1. So once again, if we start with this blue line and say that that has a slope of a over b, then the slope of the perpendicular, so again, symbol-wise, this is m with a subscript, the symbol for perpendicular, is going to be the opposite, so a negative sign. And then the reverse or the inverse of that fraction, so b over a. Okay, now, obviously, if you're given these diagrams here, the blue line is going to have a negative slope, right, because it's going down. The negative b over a just means that it's the opposite sign and the reciprocal for that fraction. Okay? So these are the relationships that you see for parallel and perpendicular lines. Okay, so if we're given this first question right here, okay, if you have a slope that is 15 over 28, what would be the slope of the parallel and perpendicular line? So just really quickly write those in the two answer fields for that problem. Okay, so the slope of the parallel line is the same, 15 over 28, and the slope of the perpendicular line is the opposite sign, flip the fraction, and those would be your answers. Okay. All right, so what I want you to do is see if you can answer this next set of questions here. Okay, only you may have to interpret what is the slope, okay, based on the form of the equation. So look to put the equation in a form that makes sense to you. How can you find the slope? Okay, the easiest way is going to be to put it into slope-intercept form. Right? Your slope is the coefficient of x. And so if it's not written in the slope-intercept form, rewrite it in that way, which means solve for y. Okay, and then you can compare the slopes. The slopes are going to be the coefficient of x for each of those, and then determine whether they're parallel, perpendicular, or neither. Neither would mean that they're not equal and they're not negative reciprocal. So any other relationship beside those two would be that the lines simply intersect. All right, so see if you can answer those 4 parts to those 2 questions. Look at this first problem right here. You see that both of the equations that are given here are in slope-intercept form. So we look at the coefficients of x. So here in line 1, we see that the slope is -3. Here in line 2, we see that it is 1/3. So again, line 1 is -3. Line 2 is 1/3. Are those equal? No. So it's not parallel lines. Are they negative reciprocals? Yeah, these are negative reciprocals, so that means that line 1 and line 2 are perpendicular to one another. Okay? And that's the relationship you're looking at. Right, in the second example here, the first equation is given in slope-intercept form. So what is the slope of line 3? An unwritten 1. Okay, but the second one is not. So in the second one, what you need to do is actually solve for the y. So if we take this equation, subtract 6 from both sides, leave y where it is. This is now in the form of the slope-intercept form. Y is equal to x minus 6. And so here you can interpret the slope of this line is the coefficient of x, which also is 1. So here you have slopes that are equal, which means these 2 lines are parallel. Okay, and so that's, again, one of the things that you might be asked is just to identify what are the slopes, or are lines parallel based on those slopes. Okay, so this is the first part of what you're going to be expected to do. The second part is to take this and then couple it with the writing equations of lines that we've already talked a little bit about, and see if you can come up with the equations of lines that are parallel to or perpendicular to a given line. Okay, so let's kind of go through the steps involved in this, and then we'll go through a couple examples. All right, so for both of these, it's the same step. Okay, you're going to determine the slope of your original line. Now, depending on what you're given, right? So you might be given a graph where you count the slope. You might be given an equation where you interpret the slope. You might be given a set of points where you calculate the slope using the equation for slope. Okay, so we have all of those as possibilities here. Okay, if you once you find the slope of your original line, you're then going to you're going to use the definitions for, or the relationship for parallel or perpendicular. Okay, remember, if it's parallel, these are going to be equal, and if it is perpendicular, going to be negative reciprocals. Okay, so you'll use either of those depending on what your relationship is. And then the final step is you're going to plug in the slope and the given point to find the equation. Okay, and you can use either form. You can either use point slope, which is what I do recommend. If they don't specify it has to be in one or the other, point slope is going to be a bit more efficient. You can write your answer a little bit easier. And remember, that looks like this, where the given information, you find the slope, you find your x coordinate and the y coordinate of your given point, okay, and that's going to be the pieces that you insert. If it is slope-intercept form, y equals mx plus b, what you'll need to do is plug in the x and the y coordinate of the given point, the slope, and then you find what b is, and then you plug that back into the equation along with the slope to get your equation in slope-intercept form. Okay, so you can do either one. As I mentioned, I would recommend just doing point slope, but either way, you plug in the slope and the coordinates of the given point to find your equation in either point slope or slope-intercept form. Okay, so I'm going to do the first example in point slope, and then you can choose how to do the second example, whether you want to do it point slope or slope-intercept. Okay, I will probably do the second example in slope-intercept just so you see either way, whatever method you choose. Okay. So in this first problem right here, if we want to determine the slope of the equation given, or the line given by this equation, what we need to do is we need to solve for y to put this into slope-intercept form. Okay, so the first thing would be to isolate your y, so we subtract 9x from both sides, and then divide by 8. And the way that I do that is I will divide each individual term by the 8. It just makes it easier to express. Now, we don't really even need to know the constant on this, although it winds up being a nice even number here. But you don't even really need that because all we're interested in for this equation is the slope. Okay, so from step 1, we see that the slope is negative 9 over 8. Well, in this problem, we want the slope of a parallel line. So when we go to step 2, the slope of this parallel line is equal. So the slope of the parallel is also going to be negative 9 over 8. So that's the second step. And then the third step is to choose one of those forms, which again, point slope is always going to be easier to plug in if it doesn't specify which form you need to write your equation. And so if I write y minus y1 equals m times x minus x1. So all I need to do is plug in these three values right here. I need to plug in the x, the y of the given point, and the slope, and I have my answer. So my slope is negative 9 over 8. The given x is 7, and the given y is negative 5, so minus and minus becomes plus. And that allows me to plug this in and solve it, again, very easily. Right. I am just going to go ahead and show you the other method with this same problem, and then I'll have you do the other one on your own. You can choose whichever method you want. Okay, so let's say we wanted to use this method where we solve as slope-intercept form. So if we took y equals mxb, we're using the exact same problems here. Here is our y value, negative 5. Here is our slope, negative 9/8, times our x value, which is 7, plus b. So what we want to do if we're writing our equation in slope-intercept form is find what the corresponding y-intercept, our b value, is. When I work with something like this, I will always find this fraction part first. So I'm not going to write negative 5 again on the left side of this equation. I'm going to leave it blank for a moment because I'm going to express it as a fraction in terms of the same denominator as whatever I get on the right side. So here, if I multiply negative 9 times 7 is negative 63 over 8 plus b. What that means for me is I'm going to express my left side in terms of the same fraction, eighths. So negative 5 is how many eighths? If we write 5 in terms of eighths, how many eighths is 5? 40, perfect. So if we express that as negative 40 over 8, what we can now do when we simplify this and add 63 eighths to both sides, it just makes it easier to combine our fractions now. This leaves a positive 23 over 8 for our b value. And once we have this b value, that now plugs in here. We have our slope m. And so the equation in slope-intercept form is going to be negative 9/8 x plus our b value, 23/8. So this would also be an acceptable answer, along with this whole expression, or the whole point-slope form. Either of those will give you full credit on a problem like this. Okay? So you can choose whatever makes sense to you. Okay? I'm not going to tell you what it has to be. Okay? So go ahead and try this second problem here on your own. You can use either point-slope or slope-intercept. See if you can find the equation of a line that's perpendicular to the line expressed by the given equation. All right, so if I am setting this up, my step one is to determine the slope. So if I take my given equation, write it in slope-intercept form by solving for y, I'll come up with my answer. So let's say I leave my 7y where it is, my negative 7y. I'm going to add 6x to both sides, and then isolate my variable by dividing everything by negative 7. I'll distribute that into each individual term. Again, it really doesn't matter what the constant is for this. I'm looking at this slope here. And so I get the slope of this line is negative 6 over 7, which means the slope of the perpendicular is going to be what? Opposite sign, so positive 7 over 6. So here's my slope. And so when I write my answer, it's just y minus something equals the slope times x minus something. And again, when I look at what those somethings are. Uh-oh, did something pick me up saying something? All right. So when you look at this, the m value, the slope goes right here, so 7/6. Your given x is negative 12, so minus 12 changes that sign to a plus 12. Your given y is a negative 3, so minus a minus gives you plus 3. And so this would be your answer for this problem. Again, if you put this into slope-intercept form, you would also come up with a correct answer. If you did put this in slope-intercept form, you would get 7/6x plus 11. And so that would be the other answer that you could have. All right. The last thing is that we're going to do, or this is the last new thing because the next slide after this is just the type of questions involving this that you'll see on the SATs. Okay, but this relationship is only one that you need to be able to do on your homework. You won't need to know this for quizzes and tests. Okay, which like so when you're looking at this formula for it, there's two different ways to do the same thing. I'm going to show you the way to do it by hand, just on the off chance you are being asked to do something like this next year. Okay, and then I'll show you that there's a formula you can use when you're doing your homework problems that I just recommend you plug it into that formula. All right, so let's look at how you would solve this problem by hand. And I'll walk through the steps as I write them down. So the first thing you're going to do is determine the slope of your line. Okay, so what this is going to be is it's going to allow you to find the distance between a given point and a line. Well, the distance between a point and a line is the perpendicular segment that connects the line to that point. Okay, so this is going to allow you to find what that distance is. So first thing in this problem here to find the slope is you need to take this given equation, put it into slope-intercept form, okay, and solve for y. So go ahead and do that if you haven't already. I'll give you a moment to do each step before I talk through it. Okay, so here, to find the slope, we rewrite this in slope-intercept form. So I'm going to subtract 7x from both sides, and then divide every term by -7. And that gives me y is equal to 1x plus 3. Okay, so this winds up being the equation of my original line written in slope-intercept form. So what is the slope here? 1. Which means the slope of a parallel line would be 1, the slope of a perpendicular line would be -1. Well, that's the second part. Okay, remember, determine the slope of the perpendicular line. Okay, and so that is the second part to this. We're finding that the slope that we're using in this case is a -1. All right, the next step after this is to write an equation of the line perpendicular. And it's going to be through the given point. Okay, so here's the given point. Here's our slope. And so when we write the equation for this line, I'm going to go ahead and write it in slope-intercept form. Okay. Or actually, I'll use point-slope form again. So if we take that, y minus y1 equals m times x minus x1. So I'll use that equation. I have my given y as -1. So I get y minus a negative becomes plus y. I have my slope of -1 in for the m value, and I get x minus 14. Okay, and so this is my equation. When I write this equation, I'm going to go ahead and I want to show you that you can even begin with point slope and wind up giving your answer in slope-intercept just by solving for y. So if I take this equation right here, distribute my negative, and then subtract 1 from both sides, what I wind up with is I wind up with a new equation. It's in slope-intercept form, okay, but I used point slope to solve it. So even if you need to get an answer in slope-intercept form, you can still use point slope to do that. All right, once we get to that stage, you now need to find the intersection of these points, and the way you find the intersection is you solve a system. So remember, the intersection of two lines can be found by solving the system. Okay, so we want to solve for the intersection point of this perpendicular line to the given equation. And so we need to set these two equations, the original and the perpendicular, equal to each other. And so if we just take that x plus 3, set it equal to negative x plus 13, and we can solve for the x value. So here if we add x to both sides, move the constants over, subtract 3 from both sides, we get 2x is equal to 10, divide by 2, we get x is equal to 5. So when we look for our system is going to have an x-coordinate of 5, and then the y-coordinate, we can plug 5 in either here or here. Notice it's going to give you the same value, right, as you would expect. 5 plus 3 is 8, so the y-coordinate is 8, or we could use negative 5 plus 13 also is 8. So whichever one we plug that into, we do get this solution point, the intersection point, to be 5, 8. Okay, and then the final step in this is to, because we were asked to find the distance between this given point and this intersection, is that you're going to find the distance between the given point and the intersection. And the way that you're going to do that is use distance formula, which you do need to know, and you will need to know for your final as well. Okay, but the distance formula is the difference of the x's squared plus the difference of the y's squared. And so that is the calculation, the final step in this. And remember, you can enter your answer as a calculation. Okay, so if you take the distance of the x's, which is 14 minus 5 squared, again, here's the x's, plus the difference of the y's, negative 1 minus 8 squared. And so this right here would be your answer. If you type this whole calculation in, your solution winds up being 12.73 approximately. If you did simplify this down, you might get root 162, you might get 9 root 2. These would all be possible ways to enter your answer. But again, to me, the preferred method, since it accepts it, would just be entering your calculation. And yet, with all of this said, that's a pretty complicated set of instructions, right? I just, again, wanted to have you see how the process works. But there is a formula that works for this as well. And so this is what I would recommend you use when you come across this question on your homework. Okay, so I want you to see if you can apply this formula right here, where you see it's the absolute value of A. Again, when you write your equation of the line, it wants it written where all the terms are on one side set equal to 0. So you take the coefficient of this x times your given point, x-coordinate, plus the coefficient of y times the given point's y-coordinate, plus the constant of your equation of the line. Take the absolute value of that, and then divide by the square root of a squared plus b squared, and that will give you your solution. So try that calculation with this problem here, please. So the only thing that you need to manipulate before you start plugging in your values is you need to rewrite this equation in the form that it's asking you for. And so that form is 6x minus 6y, add 18 to both sides, and set it equal to 0. So you're just moving all the terms to one side. And now you get your equation A, which is 6, times our given x value, which is 12. And again, this is all inside absolute values. And then B, which is negative 6. The sign carries along with it, times the y-coordinate 5. And then plus our C value, which is a positive 18 when we moved it into that form. So here's our entire numerator. That's all divided by the square root of a squared, which is 6 squared, plus b squared. B is a negative 6 squared. And so right here is the answer that you can enter. Remember, you can enter your answer as a calculation. This is all you would need to enter. And when you do this, it would give you the decimal equivalent, if rounded to 2 decimal places, of 7.07. Okay, but that is going to be, either of those will be the answer that you can use. Okay, if you want to do it by hand, you're welcome to, but the formula will be a little bit easier. All right, so that's all sort of the new stuff. The last slide here, I want you just to take a couple minutes, see if you can answer these three questions involving parallel and perpendicular lines. These are the types of questions that you will see or likely see on your SATs. All right, so these are kind of the three levels of difficulty in the types of questions that you might see with parallel and perpendicular lines. Okay, the first one is on the easier side. It gives you an equation. It asks you to find what's the slope of a line that is perpendicular to that given equation. So if we find the slope of the given line, and we do that by solving for y, so we'll isolate the 3y, subtract 21x from both sides, leave the 7 where it is, divide each individual term by 3 to get your y equals form, your slope-intercept form. And when you do that, you get your slope. The slope is -7, which means the slope of the perpendicular line is going to be the negative reciprocal, so opposite sign, flip the fraction, and so your answer winds up being 1/7. All right, the next question to the right would be one that's kind of the middle level of difficulty. Here, what you see is you're dealing with parallel lines. Kind of solving this visually is probably going to be the easiest thing to do to create your new equation. But if you know that the original line slope is based on this equation 3, that means that the slope of a parallel line will also be 3. And since it passes through the point, the origin 0, 0, we can plot this point and use the slope, which is a rise of 3, a run of 1. So this is the line that we're dealing with, and that line has an equation of 3x plus our y-intercept, which was 0. Okay, so we don't need to write that 0. I put it there, though, just to indicate what it was. And so the last part of this is if you know that this line passes through the point 5D, all you really need to do now is evaluate that line when x is 5. So 3 times 5 plus the 0 gives you 15. So that would be your answer. D represents 15. Okay, and then the final question would be one that's on the slightly more challenging side of it, mostly because it's dealing with the variables here, and that throws students off. Okay, but if you have line Q and R that are perpendicular to each other, okay, and they intersect at the origin, what that means is if line R passes through, let's say a line R is this point, or line right here, and it's -1k. Okay, so this is the point, -1k. Okay, they intersect at the origin, and they are perpendicular to each other. Okay, so if we use this origin, 0, 0, as our other point, what we can do is we can find the equation of this line by calculating the slope. So the slope of R is a rise of k and a run of -1, right? If we just use the definition of slope is rise over run. Okay, and so we get the slope to be -k, which means that this perpendicular line is going to have a slope of opposite sign, flip the fraction, so it is a positive slope, and the fraction part of the slope is 1/k. Okay, and so this is what we're going to be looking for here, is when you find the equation of this line, you have a slope of 1/k, x plus a 0 is your y-intercept. So here's the equation we're looking for, and we just need to see which of these is that equation. Okay, and this is your answer. This is 1/k times x. And so those would be your answers here for that set.